Module 5.1 Day 2 Multiplying Polynomial Expression by Monomials. Content Standard. Understand that polynomials form a system analog to the integers and are closed under the operation of addition, subtraction, multiplication, and division. Language objective. Student will be able to explain to a partner how to use the product of power property when multiplying monomials. Right, so in day one we have applied to multiply a monomial by a polynomial. So now we're doing some application. Okay, example 3, multiplying a polynomial by a monomial to solve a real-world problem. Knowing how to multiply polynomials and monomials is useful when solving real-world problems. Write a polynomial equation and solve the problem. Design. Harry is building a fish tank that is rectangular prism. He wants the height of the tank to be 6 inches longer than the length and width. If he needs the volume to be as close as possible to 350 inches cubed, what should the length of the tank? Round to the nearest inch. Okay, so let's go to analyze information. So identify the important information. Since the base are square, the length and the width we assign it as being x. Right? Then they are the same, and the height of the tank. Well, here they give us that the height of the tank is 6 inches longer. So it says x plus 6. Okay, so then the total volume of the model should be as close as possible to 3,500 cubic inches. Okay, so then formulate a plan. Then the desired volume of the model is given. The volume formula should be used to find the answer. The volume formula for a rectangular prism is length times width times the height. Using the formula and the given information to write and solve the equation. So then we know that our length is x and our width is also x and our height is x plus 6. Okay, so then we now to solve the equation, since the length and width are equal, let s represent the measurement. So then here is saying s instead of x. So here this should be s plus 6. Right. Okay, so then here we're using our s times s, which gives us s squared. So this is still, let me change it to s. So this is s plus 6. So when we use the discrete property, this gives us s cubed plus 6s squared. Right? So then this equation should be s to the third power plus 6s squared. So here we're doing checking again. So when s is 11, we do 11 cubed plus 6 11 squared. Oops, let me write as 11, and from there just use your calculator to work this out. So this gives us 2057 and 12 cubed plus 6, 12 squared. Okay, so when we look at this part gives us the greatest volume. So remember that. Okay, so we see that justified zip look, right? So we see that we, but remember that we're not looking for the greater. We're looking for the one that closer to 3,500. Okay, so then it's between these two. Right, so we say that 3,212 is closer to 3,500 than any of the other result. So the length of the fish tank to the nearest hole inches should be 13 inches. Okay, so let's try number 7, your turn. Engineering. Diane needs a piece of paper whose length is 4 inches, 4 more inches than the width, and the area is as close as possible to 50 inches squared to the nearest whole inch. What should the dimension of the paper be? So here we can do a rough sketch, right? So let's say we have a rough sketch of the paper. It's length times width, right? So here it's saying that the length is 4 more inches than the width. So the length would be the width plus 4. Remember that the area of a rectangle, always length times width, right? So length is W plus 4, and the width is just W. So we're using distributive property, so to give us W squared plus 4W. And we know that the area should be as close to 50 inches square as possible. So here we can use guess and check. Right? Let me erase that. Okay, so let's say when we have our W as being, the width is 5. So then we can have 5. We have 5 squared plus 4 times 5. So it gives us 25 plus 20, so this gives us 45. Let me make that neater. Right, so let's say we guess when W is 6, so we have 6 squared plus 4 times 6. So this is 36 plus 24. So this gives us 60, which we know. Okay, so we know that our width is somewhere between 5 and 6. But when we go to 6, it's when it is more than 50, right? So when they want it as near as whole inches as possible. So we know that the width is 5. So then the length is going to be 5 plus 4, which gives us 9. Right, okay, so can we try this one out? The length of a rectangle is 3 inches greater than the width. Right, so then to help us, we can do a rough sketch. So length and width, and we're given that the length is 3 inches greater than the width, so the length would be width plus 3. So, and then part A said that write a polynomial expression that represents the area of a rectangle. So then area is always length times width, but the length is W plus 3 times W. Right, so when you work this out, this gives W squared plus 3W. Okay, and part B, find the area of rectangle when the width is 4. Right, so then here, saying that W is equal to 4, so we're using substitution. So 4 squared plus 3 times 4. So this gives us 16 times plus 12. The answer would be 28, and this is in terms of inches squared. Okay, let's go on to our next example. So this is similar to what we just went through. So I need you guys to try this out. Okay, so we see that the length of a rectangle is 8 centimeter less than 3 times the width. Right, so label this is the length and this is the width. So the length is 8 centimeter less than 3 times. So 8 less than 3 times the width. Right, and area of a rectangle is always length times width. This gives us 3w minus 8 times a w. So distributive property. So 3w squared minus 8w. And we're given that when a w is equal to 10. So 10 squared minus 8 times 10. So 3 times 100 minus 80. So 300 minus 80 gives us 220, but this is in terms of centimeters. So it will be centimeters squared. Right, so that's the end of 5.1 day 2 notes. You have your bookwork assignment, and you are to finish your HRW and turn it in, and copy down 5.2 day 1 notes.